Hello, we're going to measure an accelerometer using CompactDAQ and C-Series modules. We're going to put together kind of a quick vibration analysis system using LabVIEW, but first let's go over the hardware that we have. For the C-Series module, we have the 9234, which is our sound and vibration module for accelerometers and microphones. It's 4 channels, independently sampled 24-bit A to D converters, each one sampling at over 50,000 samples per second. The module also has built-in excitation to power the accelerometers and microphones, specifically known as IEPE or ICP excitation. We also have a CompactDAQ chassis, which is already powered on and connected to our laptop over USB. And because the modules are hot swappable, while the chassis is on, I can just go ahead and insert this into any of the slots and click it into place, and the chassis is automatically going to detect it and configure it. And then for the accelerometer, we have a BNC connector, as is common for accelerometers. I'm going to go ahead and plug that into channel 3 of the system. And now from a hardware standpoint, we are all set up. So let's move over and look into working the LabVIEW, and we're going to start by placing 2 waveform graphs. Now, one of these graphs I'm going to place down for the time domain signal, so to see the amplitude over time. But then we're also going to, because we're doing vibration analysis, we're also going to convert this into the frequency domain. So I'm going to go ahead and place a second graph for the frequency domain. Now, the frequencies that we'll be looking at will be in the 0 to 200 hertz range, so I'm going to go ahead and set up my x-axis to cover that, and I'm going to turn off my auto scale to lock it in place and make it easier to view. And for our simple analysis program, we're finished on the front panel, so we're going to jump over to the block diagram. And to take a hardware measurement from CompactDAQ, we're going to start with the DAQ assistant. So I'm going to right-click, go to my palette, my measurement I/O palette, and grab the DAQ assistant. I'm going to place that on the block diagram, and it's going to pop up and guide me through taking my measurement. Now, an accelerometer is an acquisition, so we're going to acquire analog input, select accelerometer, and as you can see, the DAQ assistant can walk you through a variety of measurements. I'm connected to channel 3, so I'm going to go ahead and select channel 3 in my DAQ assistant and click Finish. And now I can open up my accelerometer and my accelerometer data sheet and see the sensitivity, and 1000 is about correct for this accelerometer. For the acquisition timing, I want to do a continuous acquisition because we're going to monitor frequency over time rather than just a snapshot. And really that's going to configure it for this accelerometer. So I'm going to click Run real quick and pick up my sensor. And so you can see if I shake it, I can see that my accelerometer seems to be connected correctly. And I'm going to go ahead and say that looks good and click OK. Now LabVIEW and the DAQ assistant are going to start building code behind the scenes, and it's going to recognize that I asked for continuous acquisition and offer me a while loop. So you can see LabVIEW is helping us to build our program. I say yes, and now we can go about connecting our data, wiring the data flow to our graphs. So I'm going to start by dragging the time graph in and just directly connect my data output to the time. Now, to convert from the time domain to the frequency domain, we need to do a common analysis known as an FFT. Well, LabVIEW happens to have an FFT built in, so I'm going to go to my palettes again, and on the Express palette, Signal Analysis, I'm going to grab the Spectral Measurements VI, and you'll notice that this is also an Express VI, so it's going to give us that pop-up configuration window and a variety of settings. Now for an FFT, I'm going to do a power spectrum, and we're going to change the result to linear. And for these purposes, that's going to be fine. So we're going to click on OK, and LabVIEW is going to again configure the code for that Express VI. Now I can branch off of my data from the DAQ assistant, run it into my spectral measurements, and quick Control U to clean up the block diagram. But now to view the power spectrum, I'm going to pull that graph that I originally dropped on the front panel and wire up the power spectrum to the frequency. And that'll be it. So I'm going to do a quick Control U to clean that up again, and then move back to the front panel. So if we run this, I'm going to go ahead and click on Well, first let me, actually I'm going to adjust the line width real quickly so you can maybe see it a little bit better for both of them. And then we're going to run this. Now on the top graph, what you can see is the time domain measurement. So you'll see exactly what we saw earlier in that test panel. So you can see as I shake it a little bit, the graph responds. Now on the bottom, you're seeing a frequency analysis of all of the different frequencies are involved in whatever we're doing to this accelerometer. So you can see if I try to recreate a sine wave, see if I can get a sine wave going. You can see we get a nice sharp peak at a low frequency on the FFT. And that's a very simple vibration analysis. Now let's say we wanted to test something with a little bit higher vibration. A common article that almost everybody has in their pocket with a higher level of vibration is going to be a cell phone. So if I pull my cell phone out, and if I hold the accelerometer next to the cell phone and set it to vibrate, you can see a sharp peak right at about 160 hertz. And so you can see real quick we set up a acquisition and analysis system using LabVIEW and CompactDAQ to measure frequencies. Now because this module can measure up to 50,000 samples per second, we can acquire frequencies much higher than 160 hertz. We can go up to the 25 kilohertz range, and all using the DAQ assistant and using LabVIEW. And so that is how you take an accelerometer or vibration measurement with CompactDAQ and C-Series modules.